Polymers. Polymers are fun because you can do lots of stuff with them. However, they don't look fun. Polymer is a very long molecule, and it's made up by linking together many smaller repeating units known as monomers. Okay. Polymers are, of course, means many. So we have many of these smaller units, smaller compounds here that have been joined together to make up one long one. Okay. Mono, of course, means one, so one unit basically. Some polymers contain one type of repeating unit, so they're going to take the same thing and repeat it. And other ones are made up of two different, or two, it could be even more. Okay, it could be 3, 4, 5, whatever. But some are made up of two different types of monomers that are going to repeat, and they kind of go in a pattern. So if you think about something just simple, like you could even do, some are going to be box, blue box, blue box, blue box kind of thing, and some would be all the same type of thing that repeats itself. And the other one might be something like blue box or green box. No, this was a bad idea. Blue box, green box, blue box, etc., etc. So it might be two different ones that have been joined together, and they're going to repeat in a pattern as well. Okay, so that might be another option there. And of course, you could have 3, you could have 4. They could get quite obviously complex. This is Chem 30, so let's tone it down a little bit here. Let's not get too carried away. Yeah. So here's what a polymer could look like. All right. You look at that and you say, wowzers, hey? Bazinga. I don't know, other stuff like that, right? It looks complex, and it is complex, sure it is. But what you notice here is that there's a repeating pattern. We have the same monomers here, all right, that make up this many chain unit, this polymer. In this case here, for example, if we just focused on, here's some dotted lines here, of course, and there, and there's one there, and there's one there, and there's one there. And of course, what we see in this case here is that we look at this kind of section here, and we see that this right here, right, is one of the monomers that is making up this polymer. This monomer here kind of looks like, well, it looks like it's a 2-carbon chain there, so probably something to do with some type of F molecule. And so that's fine there. But if you notice what happens with this here is if you take this actually though and you move it over to the next section, this here, right? Let's see if I can drag this here. There we go. This doesn't match up with that, of course, right? So we know that in this case that next repeating unit is different. It's not the same monomer. However, if we move it over, this one actually turns out to be exactly the same as this one here. So we see that the first and the third one are exactly the same, and of course in this case the second and the fourth one are exactly the same. So this would be an example of two different monomers making up this polymer, two different units basically. All right? Now, the name for a polymer often involves the common name of the monomer rather than the IUPAC name. IUPAC is what we've been doing. So things like cyclopentane is an example of IUPAC. Chlorocyclopentan 1-ol, okay, is an example of IUPAC stuff. They've changed that naming recently. Okay, this is fairly new naming stuff. They've changed it recently. So what happens is the polymer often involves what we call the common name. Remember when you guys did acids in Chemistry 20, we talked about the IUPAC name, aqueous hydrogen chloride, aqueous hydrogen sulfate. Remember, aqueous hydrogen bromide, aqueous hydrogen nitrate, aqueous hydrogen nitrite, right? And then we had what we called the classical name, right? sulfuric acid, hydrochloric acid, hydrobromic acid, things like that. That's kind of what this is like as well. There is another name for it. It's kind of the common name that we would call that. All right. The prefix poly is included for naming these. All right. And here's just some examples here. Now, unfortunately, mine didn't turn out very well here. So I think I need a double bond here, correct? And there's a double bond here and a single here, obviously, right? And double here and single here. Okay. So, gee, that didn't turn out very good at all. Anyway, what you can see here is that basically you guys have a better chart than I do too as well, because you guys have the last part here. And I don't think mine turned out here. Okay, so anyway, you guys can see here on your chart here that, for example, CH2 is ethene. We know that. That's what we would know it as. Ethene is a double bonded carbon, of course, bonding electrons, etc., etc. When you put many of these ethene molecules together, so CH2 to CH2, and you might say, how is that going to happen? Well, we'll be talking about that shortly here. That's the addition polymer thing that's coming up here. So I'll show you how this happens. However, when you put many of these together here, you would get something that we would call polyethene. All right? So the name poly goes in front of it. Now, you'll see there, they have the IUPAC name, which is ethene. The common name that we used to call it is ethylene. All right? You don't need to know that. What you guys need to know, of course, is this. Yes? And you guys should be able to tell me that that's ethene. Yes? I would hope by now. We don't need a number because there's only two, so where's the double bond going to go between the two of them, right? So hopefully you guys can tell me that. As far as the common name on here, you don't need to know that. Okay? However, hydrocarbons, these come from hydrocarbons. So this, of course, is a big industry in Alberta, right? When you think about hydrocarbons, we have a lot of oil here. Oil is what's used to make ethene, things like that. Ethylene, okay, is the old name that we used to give it. So if you went up to the, up north or something like that, and or into the industry, and you said, hey, we're going to make some ethene today, they would probably say, well, we call it ethylene, actually. Because it's still, the naming hasn't quite changed over quite yet. However, ethene is the new name that we have given that, basically based on IUPAC naming. So ethylene. If you put many of these ethene molecules together, in the old days we called it polyethylene. All right. What you do need to know is if we're going to put lots and lots of these together, we would probably call that today, and this is something that you do need to know, that would be called polyethene. Okay? So basically saying polyethene, many ethenes together. All right? And once again, we'll show you how that happens in a little bit here. All right? That's maybe something that you do need to know. And even that, honestly, are they going to ask you something about that? Probably not, but it's probably a good thing to know. What do you use polyethylene for? Or in the old days, we used to call it polyethylene. Well, plastic bags, right? When I did organic chemistry in university, we made plastic bags, polyethylene. Okay, that is a bunch of ethene molecules that are linked together. Plastic bags, like when you go to Safeways, Soapies, I don't know. I was going to say No Frills, but they don't do plastic bags there anymore. Well, you can, but you have to pay for them. Okay? All right, anyway. So plastic bags, okay, very common. Do we, is that probably going to be an industry in Alberta here? Probably. Okay, we got lots of hydrocarbons. We could probably make lots of plastic bags. Okay, it's probably a big industry. This CH2, of course, we would call this what? This would be, of course, that's ethene again. Okay, we don't need a we don't need to tell you where the double bond is here, but this is ethene, and we got a chlorine attached to it, so of course we would call that, where's the double bond going to be, or where's the chlorine going to be attached? It's either 1 or 2, doesn't matter. Either way, it's going to be 1, right? So we call that chloroethene, okay? Back in the old days, they used to call it vinyl chloride, all right? Vinyl chloride, when you hook many of these together, these CH double bond CH2 with a Cl off of it, we would get what we call polyvinyl chloride. And polyvinyl chloride, let me just write that down here because I don't have that on hand. Polyvinyl chloride, have you guys heard of that before? Polyvinyl chloride. I think you have. It's probably in your home. PVC piping? Yeah? Okay. PVC piping for things like, you know, drains and things like that in your home. Okay. That's polyvinyl chloride. That's PVC piping. That's made up of a bunch of chloroethanes that repeat. Okay. Basically, over and over and over again. All right. Polyvinyl chloride. It's used in pipes in your house, and it also insulates that, you know, that white plastic stuff that goes over electrical wire, right? That you got to cut back a little bit. That's also the same thing there, PVC. Okay. What would you have to call this? You would have to call it, well, polychloroethene. Okay. Many of those hooked together. And then, of course, we got propene here. Okay. Propene, once again, is, you know, double bond here, of course. It doesn't matter where the double bond goes, no, because it's always going to be that, so we don't need a number with it, of course. That was called propylene back in the old day. And, of course, this is used for ropes and carpet. And actually, as well, this polypropylene, you guys, ropes and carpet, you guys don't, you know, you don't probably, well, you guys can probably relate to that. But ropes and carpet, sure. You know where else it's used? Under Armour stuff. Yeah? For making shirts like that, for that kind of thing. It's good at wicking away moisture from your skin, things like that. Okay? So that's what they would use that for. All right? Lots of different uses for these, of course. And once again, they become very, very long chains that we use in many, many industries. All right? Now, how do these happen is the question. How do these long chains happen? So we're going to talk a little bit about addition polymers, and there's one other type that we will talk about. Alkene monomers, so double bond monomers, can be linked together through multiple addition reactions to form a polymer. So multiple addition reactions. The electrons of the double bond are rearranged. The polymer is the only product formed. So when we do these addition reactions, we're not, okay, this is the difference between these polymers. We're not adding hydrogens in. We're not adding two hydrogens or an HCl in or a HBr in or an HOH into there. We're not adding stuff on. We are simply breaking the double bond, and we're going to add another ethene onto there, and another ethene, and another ethene, and another ethene. And I'll show you what that looks like. Okay. So this looks complex, right? Look, we have a bunch of ethene monomers. This is ethene here, right? This is ethene. This is ethene. Okay. And what happens is, basically, we are breaking the double bond to get two free electrons. So what happens is, this double bond here, for example, is made up of two. That's a covalent bond, of course. Those two electrons there, it's going to break, and that electron is going to go over to here, for example. Well, it's still on that carbon, yes. It's just that it's going to break, and this one's going to go over to here. And we're going to get a single bond in between here now. So that's just a single bond. But we have these two free electrons on those two carbons. And same thing's going to happen with this one. So I'm going to get free electron, free electron, free electron, free electron. Kind of like what's happened here. Yes? Okay, so that double bond breaks one of them and basically gives you two free electrons. When that happens, of course, is the one thing that happens here, of course, is that we don't have 8 things around these molecules anymore. We don't have an octet rule anymore. We don't have a full, we don't have those 8 electrons anymore. So what happens is now these two, this here is free to hook up with this one here. And this one's free to hook up with this one here. And this one's free to hook up with that one there. And this one's here is free to hook up with this one here. So what happens is you get this long chain of repeating, okay? What was ethene, of course, you get this long chain of repeating of these units, basically. All right? And that's how you make polymers. So basically they hook up here, and once again, it can keep going this way, and it can keep going this way, as long as that reaction is allowed to proceed. At some point, you could stop it, and that's the longest chain that you would get. Okay? So that's how polymers are made. It is an addition polymer. It's not adding 8 hydrogens on. If we add hydrogens onto this chain, we'd be done. We'd stop right here, right? We did that before. You'd get CH3, CH3, we'd be done. Yes? You'd get ethane. It'd be over. We're not doing that. We're breaking that bond so that we can add another ethene onto that, breaking that bond, breaking the next bond, breaking the next one, etc., etc., as long as you let that reaction continue to go. Okay? So, all right. What you may see for some of these, just trying to think where I want to do this here. Yeah, what you may see for some of these, so some notation stuff that you might see is, how many times do you have to repeat this? And the answer is, well, could be very small, could be very large. It depends. This reaction would keep going until you stop it, until you run out of materials or decide to put an end to this reaction. So this could go on for an incredibly long time. How do you represent this? Well, what you would see is probably something like this here. Okay? And usually, this is the ethene molecule, so this is what you're starting with. Okay? And usually what you would do is put an N in front of it, which basically means a certain number of those molecules added together. All right? That would give you, of course, well, this other molecule on the other side here, which happens to look something like this here. So we'd have CH2, CH2, okay? And usually what we do is we put brackets around that to indicate that that's going to be the repeating part. That's going to go over and over. And we make sure that we kind of cut this bond here like so, which basically means that's going to keep continuing on and on. So those brackets kind of cut the bond to show that that's going to be bonded to another CH2, CH2, bonded to another CH2, CH2, bonded to another CH2, CH2. And to represent that, we put a little N here as well. So basically, however many of these you have is how many of those you're going to end up with. Okay? So that's kind of the common notation you would see for this. All right? And once again, we'd probably call this here, not polyethylene, probably polyethene is something that we would call that. Okay? So those might be some notation things that you might want to, you definitely should copy that down. All right? That's something that you may see. So once again, with addition polymers, you are breaking that double bond, and you are getting those 2 free electrons, and you are adding on another one of those monomers, basically, again, over and over and over again, okay, to get a long chain. This one here is a little bit more complex, obviously. This one has a benzene, or well, I guess a phenyl ring, I guess, right? A phenyl ring added onto it, okay? So what we see here is, once again, this one's not very clear, so, but we're going to break this bond here. We're going to break that and break that, okay? That electron's going to go this way. That, well, once again, it's on the same carbon, guys. But that electron is going to go that way, and then we have, once again, we're free to bond up another one of those monomer units to that again. So what you see here is, of course, there was, right here, there was a double bond, right? We're going to break that into that one there, and of course that one is going to go to there, right? So we broke that bond. That electron's there, that electron's there. This one also had a double bond. That one went there, that one went there, okay? And so on and so on, okay? Is that good, guys, or no? What's the monomer involved in this one? Well, it's this one right here, isn't it? The double bond here. So, well, we could name that, of course. This would be phenyl, what, ethene? Phenylethene would be the monomer that's involved in this addition polymer. Okay. This is polystyrene. Polystyrene, you guys probably have used quite a bit of that. That's actually called styrofoam. So styrofoam, anything to do with styrofoam is kind of what you're seeing there. Okay. That is the most common use of that. And it looks like that. All right. So once again, this would continue on for quite some time. Okay, any questions about addition polymers? The thing to remember with addition polymers is that double bond needs to break, and you're going to be adding on another one of those monomers. Double bond breaks, and they hook up to each other. Okay, and it just continues, is the key there. Okay, now these ones can get kind of intense here. Condensation polymers. Condensation, when I say condensation, what do you think? Condensation. Condensation. Condensation is what? Water, sure. Condensation is water. So we need to think about that a little bit here as we go through this. Now, is water the product that we're probably that we want to be involved in here? Is that why we're making these polymers? Probably not, because we just go over to the Crystal Shores beach there and grab some water. Okay, there's probably a little bit easier way to get water than making it out of this complex stuff. But probably, good thing to know, condensation polymers probably involves water at some point in stage. Okay, so monomers are combined through multiple condensation reactions. Water is produced along with the polymer. Each monomer must have two functional groups, usually at one end of each molecule. What's a functional group? What's a functional group? Give me an example of a functional group, somebody. What's a functional group? Oh, you got to know this, guys. Come on. Functional group. What do you think? Give me an example of a functional group. I'll tell you, there's two different types of groups. There's branches and there's functional groups. Branches are things that you add on to the chain. Functional groups are studying chemistry 30. Functional groups are kind of the main part, right? Main part of the chain. What's an example of a functional group? OH is a functional group. C double bond OOH is a functional group. C double bond OO is a functional group. Okay, those are what kind of change the name at the end, right? Hexanol, hexane 1-ol is a functional group. It's kind of at the end. It's what determines what that molecule looks like. It's the most important thing. Carboxylic acid, right? Hexanoic acid tells me that I got a functional group, a carboxyl group on there. Okay. OH is known as what kind of group? What is that called? OH is what group? What do we call that? Ooh, come on. Oh, you guys got lots of studying to do. Or you're quiet. I think it's studying. I'm going to go with that. OH is another word for that is what? What group do we call that? Michaela. I'll give you a hint. Starts with hydroxyl group. SOH. What about, what's the C double bond OOH? What's that called? Or C double bond OO? What group is that called? Carboxyl group, okay? Okay, so we need a functional group at each end of the molecule. So, polyesters is what we're going to focus on here. Now, there's other ones here that we could talk about, other different kinds of polymers, but we're going to focus on polyesters because we kind of already know about esters. Esters, of course, are a carboxylic acid and an alcohol mixed together. So we're going to do polyesters through what we call the esterification reaction to allow for multiple linkages, because, see, we're not just going to link one alcohol and one carboxylic acid together. We're going to link multiple ones together. Okay? So I want to do carboxylic acid, alcohol, carboxylic acid, alcohol, carboxylic acid, alcohol, etc., over and over again. So in order for that to happen, I need to have not just one alcohol at the end, I need to have two alcohols at the ends. And I need to have a carboxylic acid end here, a carboxyl group, and a carboxyl group here, so that this process can repeat over and over and over again. Okay? So it has to have probably two carboxyl groups and two hydroxyl groups as well. Okay? Let's take a look. Oh, that did not turn out good. All right, so let's do this. I'll just rewrite it here. Okay, so your carboxylic acid here is going to look something like, oops, I guess I should do this properly here. Okay, we know that that's a carboxylic acid. We have named those ones. All right, I don't expect you to. That's okay. But this is what the carboxylic acid would look like for a polyester. All right? So that's what the carboxylic acid would look like. These we have named the alcohols. The alcohols would look something like this here. Now we'll call that one prime. Is that what your notes say? Yeah. We'll call that one there. Okay? And remember, R is just a long carbon chain. Those ones we have named. Right? It could be like 1,4-diol. Yes, or 1,5-diol, or whatever the case might be. Those we have named. So that is something that you should be able to do. We have not named those, so that's okay. Don't worry about that. But what we have to have is this kind of look to them to start out with. Because, like I said, what we're going to do is we are going to arrange this so that, okay, when I add these two together, here's what's going to happen. Okay? Let's start with this, C double bond O. Got my O there, and I got my R there, and the C double bond O, and the OH, and the OH there. What I'm going to do is I'm going to mix this with an alcohol. Now, I think this is coming up still here, so it's up to you guys if you want to copy this down or not. But what I'm going to do is I'm going to mix this with kind of this here kind of thing. All right? So remember, what comes off the alcohol? Somebody tell me, please. We've done this only about 500 times now. What comes off the alcohol? Huh? OH or H? I don't know. Maybe you're right. I can't hear you. You guys are quiet. OH or H comes off the alcohol. What is it? Oh, boy. We've only done this 500 times, guys. H or OH comes off the alcohol. H comes off the alcohol. So this comes off. What comes off the carboxylic acid? H or OH? Please say OH. Okay. So this stuff comes off, right? And look what happens. Squeeze play. Yes. Look, water's a product. Yes. So I'm going to take this off. And basically, this is going to slide. Let me see if I can do that. Please let me do this. Yes. And that's going to slide over. Okay? Like so. Like I said, I think this is actually going to be coming up in your notes here, guys. It's kind of on the last page, although that one's way more complex than just the simple thing I'm doing here. Okay? Now, good. Perfect. The HOH is a product. That is condensation. I'm getting water out of this reaction. All right, perfect. But look, hey, here's another OH part here. So could I take, for example, this alcohol here again, and could I put another one on this end here? Is there anything that says that I cannot do this, for example? This is the problem with dumb boards, eh? I really would like the whole. I think I've said this. I want the whole thing. I want the roll-up panels. You know what? That's what I really want. Anyway, so could I do another alcohol on this side? Sure, you could, right? Because look, there's another what we call reaction site for this to take place. What comes off the alcohol here? OH or H? Thank you. So this stuff could react there. Okay, oh, sorry, and then I just did it wrong. After just telling you that. So that could come off, right? HOH. I take this off, and look. Now, of course, that C's got to be difficult, or that O's got to be difficult, doesn't it? That's an O there, by the way. All right, and then you get that, okay? Now another carboxylic acid comes along, and could I attach a carboxylic acid, one of these here, get rid of that dot there, that's bothering me, okay? Could I do a carboxylic acid there on that side? Sure, right? So now I do another carboxylic acid there. I do one over there. I do another carboxylic acid over here. And there's another reaction site here. So I say, oh, the OH comes off of here and the H comes off of there. And I take that out. And I take this here, compound, and this, of course, apparently. And I take this compound and I slide it over like so. Okay? And there you go. And that's how polyesters are formed basically through addition of those two alcohol, right, and a carboxylic acid. The thing with this is you have to make sure that you have a carboxyl end at both ends. So when you see that on a test, you'll say, hey, why is there one there and why is there one there? And then why does the alcohol have an OH here and have an OH at this end? Well, it's because you're going to be making a polyester, many of these over and over again, okay? And this process can continue, once again, as long as you allow it to, until you run out of carboxylic acid, until you run out of alcohol, until you decide to put a stop to it. You can make this chain as long as you want, all right? Here is production of polyethylene terephthalate, otherwise known as PET, P-E-T. Where do you find PET? Well, plastic bottles, things like 2-liter pop bottles. It's a pretty good example, okay? And it looks a little something like this, right? So, starts with terephthalic acid and ethane 1,2-diol. You guys know what ethane 1,2-diol looks like? Yeah? This one here, remember, this is not addition polymers. We're not breaking the double bond to form a longer chain. This is the addition of an alcohol and a carboxylic acid, in this case, terephthalic acid and ethane 1,2-diol. So it says right here, look, the H comes off the alcohol, the OH comes off, that stuff comes off, I squeeze it together, okay? That's one. That'd be a monomer here, of course, right? And a monomer there, and it comes to make a polymer, two different types of monomers coming together to make a longer chain of polymer. So, once again, this H here, you know, if we want to keep going here, you get this, of course, here, right? By the way, here's your what we call the ester linkage, okay, is what that is called. So please know that as well. That's called an ester linkage. And yes, you get water as a byproduct of this, okay? Ester linkage. Now, once again, like I said, you know, look, here's, now I probably shouldn't use this because that's, of course, on the product side. They're showing how these two come together. Remember, it doesn't stop here. It keeps on going. So I shouldn't use this because this is, of course, a product here, but I'm going to do it anyway because you can't stop me. This H and this OH would come off and drop out, and those could shift together, right? Anywhere there's an H and an OH, they come together and they drop, that water drops out, you get a product, and they squeeze together. And it keeps going and going and going, okay? What you have to know, though, is you have to have carboxylic acid, alcohol, carboxylic acid, alcohol, right? Over and over again, basically is how those two are made, okay? Questions, anyone? All right. Well, I guess that's it for polymers. Questions? So those are the two types of polymers that you need to kind of know about. Like I said, how many questions are you going to get about this? Hard to say. Probably, you never know, but probably not very many. However, it is a, it's obviously a thing that we need to teach you here in Chem 30. So I guess it all depends. All right. Good.